My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 447. In this lecture, we will try to understand interaction variables. Other form of feature engineering is called creating interaction variables. Let's understand what they are by taking a simple task. Let's assume we have task of predicting gender. What we have to predict here? We have to predict gender. Let's assume we have a task of predicting gender using, I have to use height, weight, hair length and eye color. Using these four features, using these four as your features, these four combinedly forms your data point xi. This is your data point xi. What is this data point? Height, weight, hair length and eye color. And your yi, this is your yi. Yi is gender, isn't it? Yes. What is this yi is gender that you want to predict. Actually, this you want to predict, isn't it? Yes. Which is a binary random variable yi, that may be male or female. That's why it's a binary variable that you want to predict. Now an example that you can build for gender, to predict gender, an interaction variable looks like this. If your height is less than 150 centimeters and weight is less than 60 kg, this is called interaction, isn't it? This is called interaction variable because these are two variables here. What are the variables here? This one is a variable, these are two, and another one is this one. These are two variables. You have variables height and you have variable height and you have variable weight. You are combining some threshold. This is some threshold. This is also some threshold values. Using which operator? Using logical operator. This is called two-way interaction, isn't it? This interaction is known as two-way interaction variable or interaction feature, because you have two variables that you are combining. You are combining height, you are also combining weight. Because you have two variables that you are combining ingeniously to create something new variable which is useful. So whenever any data point xi, if height is, I can say, if height is less than 150 centimeters and weight is less than 60 kgs, you create a new feature. That is feature, you are creating a new feature. Let me say that feature is f1. You get it a value 1, or that you will get, what is the, you will get the value 1, or else you will get value, your f1 may be 0, your f1 may be 1. You can use any boolean operator in the place of and. In the place of and, you can make use any boolean operator. This is also called logical two-way of interaction feature, because you are using logical operation like and. So let's look at some other example. Instead of logical operations, you could use numerical operations, isn't it? You could have said h into w instead of logical operators. Even I can say h into w as a new feature, depending on the use case, isn't it? The right featureization of the right combinations is very problem specific. It could so happen that combining two features with threshold and logical operations may be useful in some scenarios, something like h into w, or it can be any mathematical operation under root of h into w. These h and w, these two features you are interacting, h and w are interacting. Similarly, you could have features which is like height less than 150 centimeters. Let me height is less than 150 centimeters and weight is less than 65 kgs and hair length is greater than 5 centimeters. Now here you have three features. What are those three features? Here I have height, I have weight, I have hair length, isn't it? Now here you have three features instead of two features. First one is height, second one is weight, and third one is, I can say, third one is hair length. This is called three-way interaction feature because you have three variables which are interacting to create a new variable. It's also a logical, I can say it's a logical interaction. The interaction features are very, very useful. Big question is, as usual, given a task, how do you find good interaction feature? That's a very, very valid question. Solution to this, we have decision tree which comes to rescue. The problem is as follows. If you want to come with an interaction feature, let's say you want to come up with a very simple thing. Let's assume you have these features: height, weight. Let me say this one is height. Let me say this is height, weight. Let me say hair length, isn't it? Height, I have height, weight, and hair length. And you have yi. What is my yi? Yi is gender. You create a table with these four features, isn't it? Now, which one is xi? Height, weight, hair length. This is xi. This part is xi. And which one is yi? Yi is gender, isn't it? So you train a decision tree. You can train a decision tree on top of it. If I have a data set like this, I can train a decision tree on top of it. Let's assume if I train a decision tree, let's assume I have got this particular decision tree. Let's assume this is what we get. Let it be. If you have height is less than 150 meters and weight is less than 65 kgs, then I will come here, isn't it? I can come here. That is yi equals 0. So corresponding to this, I create a new feature, and this feature is an interaction feature because I have two variables that are interacting with logical operation, isn't it? Height is one variable and weight is another variable. These are two interacting. Similarly, I can create one for this. Similarly, I can create one for this. Similarly, I can create one for this, isn't it? I can create a feature for each leaf node, isn't it? Let's take this example. Height is greater than or equal to, let me say height is greater than or equal to 150 centimeters, and means greater than or equal to 150 means this direction, isn't it? And weight is less than or equal to 80 kgs, means this direction, isn't it? Corresponding to every leaf node, you can create an interaction variable. If this must be the case, isn't it? In this case, it is two-way interaction, isn't it? It is two-way interaction. If you create a tree which is slightly deeper, if I create a tree which is slightly deeper trees, let me say very deep trees, isn't it? You could get three-way interaction. Even you could get four-way interaction sometimes. So it's very, very interesting to see. This is exactly like what we saw in previous video. Here we are using decision tree to come up with new features, that is especially interaction features which are useful. Decision tree is considered to predict yi. Decision tree is considered to predict yi using what? Using information gain or I can say Gini impurity. Information gain or Gini impurity, whatever it is, but it's still designed to predict. It is still designed to predict yi. Hence, these interaction features are very helpful for predicting yi, isn't it? Here again, we are using decision tree as a method to perform feature engineering, especially interaction features. We will see case study on this particular concept in future lectures. Thank you very much.